Hello guys, welcome back to my YouTube channel. Today I'm here with another video with the topic comparison of large samples. The main agenda of this video is to give you a brief introduction to the comparison of the large samples, descriptive statistics, inferential statistics, ANOVA and the summary. The topics included in this video is descriptive statistics, inferential statistics, effect size measures, and a light on regression analysis, non-parametric tests, bootstrapping, ANOVA, and machine learning techniques and power analysis. Let's begin with introduction to the comparison of large samples. So comparing large samples often involves statistical analysis and methods to draw meaningful conclusions about the data. And the main goal is to often understand the differences or the similarities or the patterns between two or more groups. So the major part is the descriptive statistics. So here we provide a foundational understanding of the data's characteristics. They measures help ensures a comprehensive and accurate interpretation of the differences or similarities between the large samples. They are mainly used by two types, either finding the mean and the standard deviation or the histograms. To find out the mean and the standard deviation of each sample, to provide a summary measure of central tendency and variability. Histograms. These usually visualize the distribution of data in each sample using histograms to observe patterns and trends. So basically, what do you mean by central tendency? It is a descriptive statistics which helps to characterize the central tendency of each sample, measures such as mean or the average. It provides a representative value around which the data tend to cluster. The next concept is about the variability. Standard deviation and variance quantify the spread or dispersion of data points in each sample. It understands the variability is essential for assessing the range of values within a sample. And majorly it is about the visualization. Graphical representations such as histograms and box plots complement descriptive statistics. These visualizations offer insights into the distribution characteristics, including any outliers or patterns. The next topic is about the inferential statistics. It is a branch of statistics that involves drawing conclusions and making inferences about a population based on a sample of data. So the main thing takes place here is about the hypothesis testing. It formulates the null and alternative hypothesis to test specific claims about the population based on a sample data. And the common tests which takes place are t-test, z-test, ANOVA and chi-square test. The another major key point here is about the confidence intervals. The confidence intervals, it should be estimated between a range of the population parameter is likely to fall. And then the third point is about the p-values. It evaluates the significance of the observed differences by comparing p-values to a predetermined significant level. It also forms a critical part of the scientific method and is widely used in various fields, which include psychology, medicine, economics, and more. The next topic is about regression analysis. It is a statistical technique which is used to examine the relationship between one or more independent variable and a dependent variable. It can be aligned in comparison of two large samples to understand the association between the variables. There are majorly two types of regression. One is linear and the other is multiple. So let's learn about the linear regression. It is commonly used when investigating the relationship between the two continuous variables. It assumes a linear relationship and estimates the equation of a straight line. Whereas in the multiple regression, multiple independent variables, multiple regressions allows for the examination of the combined effect of these variables on the dependent variable. It helps control for the influence of other factors. And the third point is about the interpretation of coefficients. The coefficients in the regression equation provide information about the strength and the direction of the relationship. The slope coefficient indicates the change in the dependent variable for a 1 unit change in the independent variable. The next thing is about the bootstrapping. Here there are 5 key points. The first key point is about resampling with replacement. It creates multiple bootstrap samples that mimic the variability present in the original data. And the second key point is about the construction of confidence intervals. Confidence interval is derived from the percentiles of this distribution. Third key point is about applicability to large samples. Efficient way to approximate the sampling distribution without relying on any complex mathematical formulas. Fourth point is about the parameter estimation. It estimates the parameters of interest such as mean, variance, or regression coefficients. And the fifth and the final key point here is about the robustness checks. By comparing the results obtained through bootstrapping with the traditional methods is the fifth point. The next topic is about machine learning techniques and power analysis. Here also there are 5 bullet points. The first point is about the supervised learning, where a training model is labeled and it is allowed to make predictions. The second is about the unsupervised learning, which determines clustering and dimensionability, which reduces the methods. The third point is about deep learning, a subset of machine learning. It involves neural networks with multiple layers. The fourth point is about ensemble methods. The random forest or the gradient boosting are the ensemble methods which are used to combine multiple models to improve the performance. And the final one is the power. It is influenced by several factors, including the significance level of alpha, effect size, sample size, and variability in the data. The other topics are the non-parametric tests. There are two kinds of tests. The first one is Mann-Whitney U test. It is used to compare two independent samples when assumptions of normality are not met, and an extension of Mann utility U test for comparing more than two independent samples. The next topic is about the effect size measures. It measures the standardized difference between the two group means. It represents a proportion of variance in dependent variable explained by the independent variable in ANOVA. It measures the strength of association in contingency table. ANOVA. It is majorly used in the comparison of large samples. The ANOVA full form is of analysis of variance. It is employed to assess whether there are statistically significant differences in the means of 3 or more groups. It helps determine if there is variability independent variable that cannot be explained by chance alone. There are two types of ANOVA, one-way ANOVA and two-way ANOVA. One-way ANOVA is used when comparing means across 3 or more groups from a single independent variable, whereas two-way ANOVA extends the analysis to include two independent variables, examining the main effects and potential interaction between them. So the major applications of ANOVA is in sum of squares and F statistic. Sum of square, ANOVA partitions the total variance in the data into different components, including the sum of square between the groups. F statistic, the F statistic is calculated by dividing the variance between the groups by the variance within the groups. A large F statistic suggests that there are significant differences between group means. So here is the summary of the video. Comparison of large samples is a critical aspect of statistical analysis with broad application across various domains. In scientific research, particularly in fields like medicine and genetics, comparing large data samples is instrumental in understanding the efficiency of the treatments, identifying the genetic variations associated with diseases, and making informed decisions about public health. This comparison of large data is also useful in educational field as well as the environmental sciences. Overall, the applications of comparing large samples are diverse and contribute significantly to evidence-based decision making in various fields. Thank you guys. Stay tuned for more such videos. Please do like, share and subscribe.